not all inputs can be given to a function at the time of calling the function. A certain application may require the user to give an input which depends on how the program progresses. For example, if you were to code a simple tic-tac-toe game, you can't ask for all of the inputs at the time of starting the game. The inputs here being the locations of the moves of the user. For example, if I'm going to play in the center, maybe that's my first move. But then my second move is going to depend on where the AI or where the computer played its first move. Okay, so in this case, I cannot give all of my moves to the tic-tac-toe game when I start. I have to see how the game unfolds, and then I'm going to input, I'm the user, I'm going to input my locations as the game unfolds, so to speak. So in this case, we would want our tic-tac-toe game or our program to pause and wait for the user to input, in this case, a location. Okay, but we're asking the user to input something to our function. Okay. Similarly, we may output something to the user as well. So sometimes an application will require providing the user with a message. You win, you lose. For example, if you're coding a hangman application, you might, upon the user guessing a wrong letter, you might say you have 3 incorrect guesses remaining. Okay, so that's an idea of where you'd want to output something to the user. Also, maybe you have a certain application and you want to echo lots of variables to the user. The derivative of blank is blank, or at time blah blah blah, the integral is such and such. Okay, so if you have a lot of different things to look at, a lot of different variables that you're echoing to the user might get confused, because in MATLAB it just echoes simply d equals 3. And you say, oh, what was d again? I forgot. Or a equals 5, 2, maybe it's a vector, 7. What was a again? What am I looking at again? In this case, you might want to instead print a little message that says, instead of d equals 3, maybe you want to print a little message to the user, say the derivative is 3. And that way you remind the user of what it is he or she is looking at. Okay? So the subject of today's lesson is user input and output. User input output. We'll start with output. To output something to the user, so that this is strictly for the human, I'm going to use the function fprintf. So I'll come over here in MATLAB and I'll just show you how it works here. I'm going to type fprintf parenthesis, and I can print a message to the user. So I'll start my message with a single quote, and I'll just type you win, and I'll end the single quote and then close the parenthesis, and I'll hit enter. And look, it prints you win. And notice that the prompt came directly after that. Right? With no space, no new line, nothing. So now it's asking for a new command. So I'll just hit enter a couple times. So in this case, I used fprintf to display a message to the user. It's much more powerful than that, though. It can print variable names, and it can print the values that variables are storing. So let me show you that. let's say I have a variable a equals 10 or 20. Let's say a equals 20. I can print, for example, f print f. Maybe a is the acceleration of something. I can say the acceleration is, and I'm going to type %d, which I will explain in a second, meters per second squared. And I will end the single quote, and then I will print, then I will type a comma, a, and then close the parentheses. So the acceleration is %d meters per second squared, and I will hit enter. Notice what happened here. Okay, first of all, I get my message. The acceleration is blank meters per second squared. But what this function did was, it took what was stored as a, which was 20, and it substituted its value of 20 into the %d. Pretty cool. The %d is called a format specifier, and D stands for decimal. So we're telling MATLAB that we want to replace this blank with a decimal number, okay, 20. The % sign, when it's in quotation, so we've already seen the % sign before. % was for comments, right? But when the % sign is contained in single quotes, it allows for, it turns this pinkish purple color, and it allows for a format specifier. It's going to be a placeholder for a value. Okay. Now let's say I have another variable, maybe b equals -10. And I can try something else here. Let's try f print f. Okay. And I'll just type the value of a is %d, and the value of b is %d, and I will end that with a single quote and a comma. And now the variables that I will list correspond to, in order, a is the first %d, and b will be the second %d. So I will type a, and then comma, b, and close the parenthesis there. And I'll hit enter. And there we go. It says the value of a is, and then it took a, which was the first variable listed after the comma, after the single quote, and substituted its value for the first %d listed. And then it took b, and the value of b is, and then it took the value stored in b, which is the second variable listed, and substituted it in for the second %d that was listed. Okay, then we still have this kind of pesky thing where the command prompt is not on a new line. You see that? It gave me the command prompt immediately afterwards. To fix that, after my %d there, still within the single quotes, I'm going to type \n. Okay, and that stands for a new line, or carriage return. So if I hit enter now, you'll see the value of a is 20, and the value of b is -10, and then it printed a new line, and the command prompt is down here. If I wanted another new line, I could print 2 \n and hit enter. And now it prints it out, makes a new line, which is here, and then it makes another new line, so there's that space there. Okay. Let's suppose I have a vector. Let me clear the workspace. Clear. Let me clear the command window, CLC. Maybe I have a vector A equals, and it's got two components, we'll say 5 and 2. So there it is. And maybe I have some sort of application that requires me to add those two components together and display back to the user the sum of, in this case 5 and 2 equals 7. Well, first of all, notice that if I type f print f, the sum of %d and %d. I'll just stop there with a \n. And if I put a, now a has two components. Right? So what do you think is going to happen in this case? Yep, it's going to take the first component of a and substitute it in for this %d, and it's going to take the second component of a and substitute it in for the second %d. The sum of 5 and 2. And then it prints a new line because of my \n. Okay, well, suppose I wanted to show that sum. So I could type f print f, the sum of blank and blank is, and I'll put another %d because there's another placeholder there. And the next thing I want it to print, so I'll put a comma after the a. Remember, the a has two components, so the a takes care of the first %d and the second %d. And in the third %d, I want the sum of those two components, so I can type a of 1 plus a of 2, the first component of a plus the second component of a. And I'll hit enter. And there we go. We've got this, a message to the user. The sum of 5 and 2 is 7. I didn't even have to type any numbers there, right? It did it all based on what was stored in the workspace. So the %d is a format specifier. And in your book, you have a table of many different format specifiers. They all start with a %sign, but it does not have to be D. D stands for decimal. Later we'll learn how to use strings and characters, and they have their own format specifier. But another format specifier that I want to show you is the %f. So let's say I have a decimal number, 0.5000. Maybe it represents 50 cents. But in an application where you have cents and dollars, you don't really need all of those decimal numbers here. I'll call it C, a coin. So if I type C, there's C. I don't need all those significant digits because I'm dealing with cents. So in this case, I might want the message, if I'm displaying a coin value, I might want it to truncate up to the hundreds position. So I can say f print f, the value of this coin is, and I will type a %sign because this is going to be holding the place for a value, and I'm going to type 0.2, and that means 2 spots after the decimal. So if we wanted 3 spots after the decimal, we'd type 0.3. So I'm going to say 0.2 and f. And f means a floating point, which you do not need to understand at this moment. So the value of this coin is %.2f. Okay, and then we'll type a period there and a \n. Close the message with a single quote, comma, and then I want to substitute whatever's held in C into the %.2f. And I will close the parentheses there. Enter. So now you see what's displayed to me is just 2 significant digits. So you can see why this is called a format specifier. We're specifying the format that is printed back to us. Right, just to show you, if I change this to 0.3f, now it gives us 3 decimal spots to the right of the decimal location. And you might be curious about this. Does it round or does it just truncate? So let's give a different value. Let's say C equals, it's a weird coin, 227. And the question is, if I print 2 decimal locations, is it going to print 0.22 or is it going to print 0.23? Okay, so let's check it out. It prints 0.23. So we can conclude then that this format specifier is rounding. It rounds. Alright, let me clear the workspace and clear the command window. And I want to demonstrate this new concept to you from an old function, coin value. So I'm going to open coin value. Okay. And here's our work from last time. Now if you remember, last time we wrote a function that took a diameter of a coin and the mass of a coin as input, and it outputted the value of the coin. Okay. And the diameter and the mass could be 5% away from their nominal values according to this table down here. So just to refresh your memory, I could say value equals coin value, and maybe I type 30.61, so that's a nominal $0.50, and 11.34, that's the mass of a $0.50. So I hit enter and I look at value, and it tells me that the value is 50 cents. So I gave it the diameter of a $0.50 and I gave it the mass of a $0.50, and it outputted 50 cents to me. Okay, well, sometimes, depending on the application, printing a message instead of outputting the value may not be appropriate. So at this point in time, you should have a firm grasp on how functional inputs and functional outputs work. Okay. In this example, V is a functional output. It returns the value back to me, it stores it in the workspace, and I can call it later on if I want to. Let's say this program is the first stage in a much larger program to calculate the total value that a person has inputted into a vending machine. Okay, so a person inputs a quarter, and then our function says, yeah, that's 25 cents. Then the person inputs another quarter, and our function says, yep, that's another 25 cents. So we could say value 1 equals, and so the coin that comes in is a quarter, maybe just smaller than a nominal quarter, 24.25 millimeters and 6.24 grams. So the first coin comes in, okay, and our function says, yep, that's 25 cents. Notice again, value 1 is stored up here in the workspace. Let me clear the command window. And a new coin comes in, and it's another quarter. Maybe it's a little bit larger than the nominal. Okay, and that's value 2. So another coin comes in, and we can look at value 2. It's 25 cents. Now you can imagine several coins being inputted, and our function returns the values of these coins. And now after our function comes another function where it adds all of these values up and determines if the person has enough value, has input enough value to obtain what it is that he wants, the Dorito bag or something. In this case, the functional outputs would be sent to another function. Okay. Value 1, value 2 would go to a new function that would add all those values up and make a determination. This is not the same thing as user output. This was functional output. User output is strictly for the human to see what's going on. So imagine in this application, we calculate our values there. V, if it's a penny, V is 0.01. If it's a nickel, V is 0.05, and so forth. Maybe we want to display that. We want to say f print f, the value of the coin is, and we'll say percent 0.2f, because we only need 2 decimal locations. And we'll give it V, whatever's contained in V. I'll save that. Okay, and I'll clear the workspace, clear the command window. So now I call my function, and I send it a $50, let's say, and I hit enter. And it says, oh yeah, the value of the coin is 50 cents. Okay, great. But in this application at a vending machine, I'm putting in these coins. I don't need to see that. Right? I don't need to see, oh yeah, 50 cents. I know that I put a $50 in. Okay, I don't need to see it. Further, this is no substitution for functional output. So I see programming students confusing confusing functional input and functional output versus user input and user output. So what I might see is something like this. Well, let's get rid of the output. We don't need the output, so we'll get rid of that in the function header, and we'll just simply display it. So I'll save that, put a \n there, and we'll save that, clear the workspace, clear the command window. Okay, and I'll call my function. Oh, I have no outputs now. So I have no outputs, so I will call my function like this. Okay, I'll call coin value, I'll give it a $50 diameter and a $50 mass. I'll hit enter, and it says, oh yeah, the value of the coin is 50 cents. That seems good. But the problem here is that that value is not stored in the workspace. So if I wanted to access the value, maybe to send it to another function that sums all the values up, I can't do it because that value is not in the workspace. This is purely for the human. It's purely for the human. It does us no good computationally when we don't have it stored in the workspace. So now if I want to call that value, I want to say, what was value again? Oh, it's undefined function or variable because it's not in the workspace. So now I cannot send that value to another function to have that function sum up all these values because I lost the value. I never outputted it in the function. I never returned it from the function. I simply printed it. But simply printing something does no good. Only for us humans does it do good. Right? So, oh yeah, I get confirmation that I put a $50 in. Okay, big deal. Okay, so this user output is no substitution for a functional output. So I'm going to put that functional output back up into my function header. Okay, I'm going to get rid of this line. clear the command window, clear the workspace. Good. So now that was functional output. fprintf was for output. Let's take a look at user input. And for that, we're going to use the built-in function input for, input. So let me go to the command window here. And let me just give you an example. Let's say I type A equals input, parenthesis, and you see there's a prompt. It gives us a hint, it says prompt. So I'll put a single quote. I'll say, give me a number. Put a semicolon after there. Okay, and when I hit enter, it says, give me a number, and I've got that vertical bar that's flashing. And I want you to notice that down here, it says waiting for input. So I cannot execute any commands right now until I give it a number. So I'll give it a number, 10. Hit enter. Okay, now I've got my command prompt back, and it does not say waiting for input anymore. But look what has happened. A equals 10. So I said my initial command was A equals input, and then I typed a message to the user. Upon executing that line, it displays that message to the user, and it waits for the user, for the human, to input something. Okay, so I inputted 10. Then whatever I input gets stored into, in this case, A, which was my original variable in my original command there. Let's clear the command window, clear the workspace. And let's write a new, let's do a new script. Let's do a new script. Suppose we had a tic-tac-toe game. So I'm going to call a variable board. Board equals, and let's say a blank location is a 0. So I'll just say 0, 0, 0, 0, 0, 0, 0, 0, 0. So there's a tic-tac-toe board of 3 by 3 of zeros. That's blank. And I want to first ask the human, give me a location, give me a row, and give me a column. So what I can say is row equals, and I will use the input function, input, single quote, give me a row. End the single quote, end the parentheses, semicolon. So what that's going to do is it's going to pause code execution. It's going to wait for a row. Then upon entering a row, I will ask the user to input a column. Give me a column. I've got the single quotes there and the parentheses and the semicolon. Okay, give me a column. And then I don't want to use X's and O's for right now. I want to stick with numbers, what we've been using thus far in the course. So maybe player 1, I'm player 1, and I'm going to put a 1 now in the board at that location. So I will take board of row, comma, col equals 1. So you see, line 2 here, whatever number that I input is going to be stored as row. So if I input 2, row would be 2. Then it's going to execute line 3 and it's going to ask me for a column. whatever number that I input there is going to be stored as col. So if I want to place in the center, then I'll set col equal 2. And then line 5 would say board of 2, 2 in this example. Okay, that's the center square, equals 1, so it's going to place a 1 there. And then maybe I want to display a message back to the user and say the current, let's say fprintf, the current board is \n. Okay, and then I want to echo board back. Alright, let me save that. Save as, I'll call it tic-tac-toe. Save. Alright, I'm going to run it and see, let's see what happens. So I push run. Okay, it says give me a row. Alright, I'll go 2. Hit enter. Then it says give me a column. I'll hit 2. It says the current board is, and then it echoes board, and lo and behold, there's a 1 at 2, 2. And that's the end of our game. Very neat. Let me clear the command window, clear the workspace. And let's try that again, but I'll input a different location this time. I'll hit run. Give me a row. Maybe I want to play in the top left location. So I'll hit 1, row 1, column 1, enter. The current board is, and then there's a 1 right there in the top left, row 1, column 1. So this will work for any row 1, 2, or 3, and any column 1, 2, or 3. Good. This also works, the input function also works for vectors and matrices. So let's go back to the command window here, and let's say A equals input, give me a vector. And I'll hit enter. And it's asking me now, give me a vector. So I'll put how do we input vectors in MATLAB? We start with a square bracket, and maybe pi 0, 10. Square bracket, semicolon, if you like. Okay, and so now I will have, notice A is in the workspace, and I'll have a look at A. A equals, and there's our vector. Pi 0, 10. So let me change my tic-tac-toe game a little bit. Suppose I didn't want to ask the user twice, okay, once for a row and once for a column. Maybe I just want to ask the user once, input a vector of your location. So what I'll do here is I'll say location equals input, single quote, give me a location as a vector. And then I will delete this, and so now location will be a length 2 vector. It should have 2 components. The first component's the row, so we'll say row equals location of 1, and the second component is the column. And the rest is the same, so I'll save this, clear the workspace, clear the command window, and run our script. Okay, give me a location as a vector. So if I want to play in the center, I'll put square bracket, 2, 2, square bracket. The current board is, and there's my 1. Let me clear the workspace, clear the command window, and run my function again. Maybe I'll place in the top right this time. So I will input row 1, column 3, enter. The current board is right there. So this is user input. It's asking the human to input something. Right? Let's go back to our coin value problem. Save this. Coin value. What you have to understand is that user input, again, is different fundamentally than functional input. Just like user output, we argued, was fundamentally different than functional output. You might be tempted to, if you had this problem, say, well, instead of giving my function inputs, d and m, let's give it no inputs, and instead let's ask the user for an input. So d equals input, give me a diameter. And m equals input, give me a mass. Okay, you may be tempted to do something like that. So we'll save it. Alright, and this will work as you probably expect it to. We'll clear the command window, clear the workspace, and I will call my function. So value equals coin value. But now our function has no inputs, no functional inputs. Right? So I won't give it any inputs from the command window, I'll just hit enter. It says give me a diameter. Let me pull up this table again. So maybe I'm giving it a quarter. So we'll say 24.26. There's the diameter. Give me a mass. And the quarter's mass is 6.25 grams. It says the value is 25 cents. Yeah, that's okay. But the issue is that, well, for this particular application, imagine you're at a vending machine, and instead of inserting the coin, the vending machine just said, "Hey, give me a, what coin are you going to insert?" And you say, "Oh, I'm gonna insert a dollar," and you really insert a penny. But you don't want to ask the user necessarily for these things. Instead, in this application, it would probably be more appropriate that you have some sort of function first that takes the physical coin and senses the diameter and senses the mass, and then those go into our function. Here's our function. Okay, and then we output the value. And that probably goes into some sort of summing to determine the total value. Okay, so in this particular application, it doesn't really make much sense to have the user input the diameter and the mass. Those are things that would be sensed and sent electronically to our input, automatically sent to our input of our function. So the point here is that user input is fundamentally different than functional input. And depending on the application, it is wrong. It may be wrong to do one instead of the other. By default, if you are asked to input or make a function that inputs something and outputs something, these are functional inputs. It will be explained if it should be inputted as by the user or outputted to the user instead. It'll explicitly say that. Write a function that has no inputs, but instead asks the user for blah, blah, blah. Okay. So, let's review the key points here. Key points. Number one is that we can use printf for user output. For user output. And we can specify the format of a certain variable using format specifiers that are listed in your book, but we looked at a couple of them. %d holds the place of a decimal. And this holds the place for 2 positions to the right of the decimal location. And we also said that the \n will help us print a new line. The most important thing here, though, is that user output in this case. User output is no substitute for functional output. You should understand functional output at this time very well. User output, which is the subject of today's lesson, is no substitute for functional output. I showed you via this coin value problem that user output simply displays messages and values to the command window, to the user. It is not stored in the workspace as a functional output is. The functional output is more useful to us because it's stored in the workspace, then we could send it to another function and we can use its values that it's storing to do other calculations. And if we need to display it, we can certainly type it and leave off the semicolon and echo it to us, so we can also display it. Whereas user output only displays it, we can't use that number for any more calculations because it's not stored in the workspace. We looked at the input function. The input function. And that pauses code execution for an input from a human. Again, the most important point here, though, is that user input is no substitute for functional input, which you should understand well at this point. Function input. Okay, so we looked at two examples here. One was the coin value problem. it did not make sense to have the user, the human, input a diameter and input a mass. The other application we looked at was for tic-tac-toe. In this case, it does make sense for the user to input a location because the user is playing. So the user will input, oh, I need to place a mark here. Okay, well that requires the user to, intervene with the program here. So we would use user inputs when not all inputs can be given to the function at the time of calling the function. Okay, I say function here, but a script too. I mean, we looked at a script for the tic-tac-toe. Yeah, so you're calling a function, so you're calling a tic-tac-toe game. You cannot possibly tell the game right at that moment where you intend to play all of your marks. It depends on how the game progresses. Well, if that's the case, then the code is going to have to stop, pause, wait for you to input something, and then continue. And that's what the input function will help us with.